So we are studying like shaping processes of plastic. This is part 4, lecture 5 and part 4. And today we are going to study compression molding method for plastic product manufacturing. First of all, compression molding is nothing but kind of die casting. You put the material or which we call the charge into a cavity. It's like similar to casting into a cavity, and then you use the upper a punch. Okay, you use a punch shaped. The shape of the cavity should be same as the part you want to produce. And then you apply pressure force to distribute the material all over the cavity, and then you take after the solidification you take the molded part out. Like first, the compression molding is basically used for thermosetting plastics, which can be melted only once. Melt it, then produce a part, then you cannot remelt it. So for the thermosetting plastics, this is not only for tiles or rubbers or rubber tires, but also this process is widely used for manufacturing polymer matrix composite parts. For example, if you want to mix some chopped fiber uh, with the charge, that means the thermosetting plastic, you mix them together and then you put the charge, that means hot and molten charge, into the cavity, and then you apply pressure to so that the molten material distributes all over the cavity, and you allow some time for solidification, and then you get the final product. So this is the basic of compression molding. And then for ejection, there should be an ejection pin, which actually ejects the molded part. And before you put the charts, you need to use actually lubrication for easy removal of the final molded part. And the lubrication is like mold release agent. This mold sorry mold release agent, usually people call it like something like this. There are many variation of this mold release agent. For example, for if you want to mold PVC, there will be different mold release agent compared to if you want to use polypropylene or polyethylene. So it will be different for different material you're handling. Okay. So do you have any question in here, like for compression molding? It's a very simple process. All right. The characteristics of this compression molding is, first of all, the initial charge can be various types, like you can use powders, pellets, liquid, or preform. All of this can be used. If you use powder, then you compress it and then you heat the whole mold for the curing. If you use pellet, the same thing. You can preheat the material and then use it as in the liquid form. And you can use also the preform. That means already kind of pre-shaped material can be placed in the cavity, and then you use heat and pressure to give the final form. That's why it says the preheating of the charge softens the polymer and shortens the production cycle time. If you preheat the polymer before inserting into the cavity, then you need to the production cycle time will be reduced. And there is no sprue or runner system in this kind of compression molding, and there must be provision for heating the mold to properly distribute the material and to reduce the amount of force required to distribute the material in the whole cavity, inside the whole cavity. That heating can be accomplished like using hot steam or electric resistance heating, induction type heating, or hot oil circulation around the mold cavity. Okay. So there can be many kind of heating method, and in this case, the materials are usually phenolic, melamine, urea formaldehyde. There are various types of material can be molded using compression molding method. And the typical disadvantage, the only disadvantage that I already mentioned in here, like production cycle time. If you compare with, injection molding, then the typical disadvantage is the longer cycle time. It takes a long time for handling, producing compared to the injection molding part of plastic. Okay, that's all for compression molding. Do you have any question? Okay, do you have any question?
No, sir.
No question, sir. Thank you.
All right, next one is the blow molding. This molding method mostly used for producing a single part, like single bottle for beverage or drinks. We for transporting them or carrying them. We use these kind of bottles, and which are or kind of storage bottles can be made using this blow molding method. It uses actually air pressure to expand the perizone. This is called perizone. That means the initial form is cylindrical pipe type shape, and you that is called perizone, and that perizone is expanded into a cavity of the shape that you want to make for a bottle. Okay. Uh, the soft plastic that comes out of the extruder barrel, we already know the function of the extruder. If you want to produce a hollow cross section, then you know how to use the extruder for producing hollow cross section. That hollow cross section comes out of the extruder through this way, and once it reaches the other end, then it's clamped in here, and the top part is cut down. Okay, cut down, and at the same time pressed together so that they combine, they get combined in that place. Okay, the material gets combined in that place, and once this is done, then the airflow comes into play. The air gets into the cavity and expands the material and distribute the softened material all over the mold. Okay, and then you use the cooling cycle to cool the material, and then you take it out. Okay. So do you have any question in here? Like it's
Sir, this is particularly used for the PET bottles, sir, that generally we use for drinking water, or this PET
the
bottle.
PET bottle, it's a two-step process actually they use for faster production. I'll go into that, but these are the things used for like storage bottles or containers. Okay.
Containers, right, sir. Right, sir. Thank you, sir.
Sir, I have a question.
Yes.
How, when the air come in, like the blowing, how it can be ensured that there will be a uniform thickness of the bottle,
Okay,
or the container?
that's a really good question, because when as we know, the for any fluid or liquid, pressure is distributed all over the area evenly, right? And the material is in the softened state.
Yes.
When you apply the pressure, the pressure is distributed, is applying force in all the direction at the same way, right?
Okay.
And
Yes, sir.
that's why the material is liquid. Okay, kind of softened material. The plastic material is softened, so due to the pressure, the material actually evenly distributes all over the mold.
Okay. So in that case, the gravity doesn't affect the
Mm,
mold
there
significantly, I think.
there will be high pressure like 2 atm or 3 atm.
Okay, sir. I understand.
So in that case, gravity effect will not come into account.
I understand. Thank you, sir.
Okay.
Sir, it is the metered quantity from extruder barrel. Is it coming, sir? Metered quantity.
Yes, definitely. From the extruder barrel, you need to calculate that. There is the method of calculation, how much thickness you want for the final product, and according to that, you need to design the die, and you need to design the thickness of the perizone that is coming out.
Sir.
So there's a back calculation.
Sir.
All
Thank
right.
you, sir.
Next, for the blow molding, usually some advantages, there are some advantages like high production rate, great accuracy and in the final dimension, and larger lower scrap rate. That means compared to the other injection molding methods, the scrap rates that means the defective parts is less, and less wasteful of material. The material waste is also less because there is no sprue or anything like that. So the material is not wasted. So all the material that comes out of the extruder is being used, except a little bit some actually gets wasted, like when you cut it in here, then in this place, then there is a very small amount of material is being wasted. But that's compared to the injection molding. If you look at the sprue and runner, then there's a lot of material that are being wasted. But the other benefit of injection molding is that it's a very faster process. Okay, this one is also faster process, but the application is different. Okay. And on the other hand, the larger containers can be produced with extrusion blow molding because the mold in injection molding is so expensive for large perisons. Okay, if you want to produce a large product, instead of using injection molding, it is better to use blow molding. Okay, because in the case of blow molding, you don't need huge amount of pressure. Okay, but in the case of injection molding, since you have very small amount of time for injection of the material, and you need a huge amount of pressure, and at the same time you need a large uh, screw to deliver the large amount of material. So there is a huge initial cost involvement. In the case of blow molding, this is less. So this is one of the advantages. Extrusion blow molding is technically more feasible and economical for double layer bottles. If you want to produce bottles with double layer, for example, if you want to produce a bottle like this, usually used for medicine. Medicine bottles are like two different layer, inside and outside. The one layer will be inside layer, and another is outside. Okay, sorry, I'm very bad in drawing, hand drawing. If you want to have the two layer of plastics in a bottle, then it is very convenient to use the extrusion blow molding. Okay, like you use when we extrude the material, we have already seen that how two layer of material can be extruded from a die. Okay, from a extruder, the two layer stays like this. Two layer stays like this, and then you press it together, and then you use the blow molding, then you can get it very easily, which is very difficult to obtain in the case of injection molding. Okay. Okay, so far, do you have any question?
Sir, no, thank you, sir.
All right. Then this is another type of blow molding, injection blow molding. Okay. It actually uses the benefit of injection. Okay. At the same time, the process is very fast compared to the previous one we have studied. In this case, what happens is that the molten material is injected through a plunger, using a plunger in here, into the cavity of a perizon. The perizon is made in here. Okay, this one is called perizon. Okay, the perizon is made here, and then that perizon is transferred into another mold. In this process, only perizons are made. Then perizon is transferred into the actual mold, where a plunger is used to facilitate the airflow. It is installed in that place, and then you apply the air pressure. Then it gets expanded in the all over the mold. Then you cool, allow some time for cooling, and then you take it out. Okay, it's a similar process, but it will be much faster compared to and something like that. The perizon looks like this. Okay, the perizon looks like this. First step, you produce the perizon, and in the second step, you expand it. Okay, and sometimes this is done in the two stages. Like in the first stage, you just produce perizon. A lot of perizon is produced, and that perizons are transferred into this mold, and there is heating system, so that the mold is hot and the air pressure is applied, then material get extended to the surface. Okay. This one is similar to that. The only difference is that it uses the stretch. The stretch is like, first you produce the perizone, and then perizone is stressed using a barrel. Okay, the airflow barrel that is used for airflow, that barrel is pushed. Like for example, in this case, the barrel is up to this point, but the barrel is pushed to elongate the material. Okay, elongate the perizone. Perizone is elongated, and then you apply the pressure. It produces much more. The benefit of this process is that it takes less amount of time, less amount of air pressure, at the same time uniform distribution of the material. Okay, so it's much better compared to the previous one to obtain the better composition and better thickness of the material. Okay. Okay, that's blow molding. So if you have any question.
Sir, I have a question.
Okay.
Sir, is it necessary that the thickness of the perizone and the molded part will be equal?
Thickness of the perizone and the molded part. That means this is the
Thickness of the molded part, yes, sir.
and the thickness of the molded part.
Yes, sir.
No, it will not be the same. The thickness of the perizone will be higher than the molded part because this materials is getting expanded. Am I right?
Yes, sir. Simple blow molding, in simple blow molding.
In the simple blow molding, in here,
Yes, sir.
it's the same. The material, the thickness of this tube is higher compared to the thickness of the final molded part because it is getting expanded. The material volume is same, but if you increase the stress it, then it will reduce the thickness, right? For example, if you like, for example, very simple example is like if you want to do a tension test of a material, then what will happen? If you pull from both sides, then it will be extended in this side but reduced on the other side.
Yes, sir.
Okay, so thickness will get reduced.
Yes, sir. Thank you, sir.
All right. So the next one is thermoforming. So using temperature, you give the material a certain shape. Okay. First one is the vacuum type, and vacuum type has different types. Like for example, first one is the negative type. That means if you use make the cavity like concave, is it convex or concave? Pranto? Uttol and Avotol. This is
It Avotol, sir. Avotol is concave.
Avotol, sir. Concave.
Right?
Yes, sir. Avotol.
With the concave type.
Banglaয় ভালো বুঝি, sir. Avotol.
Yeah, the physics people will understand. All right, this is concave type. So then if the mold is cavity is concave type, then it is called negative type. And if cavity is there's no cavity, instead of the cavity there is a kind of convex type structure, then it will be positive type. I'll show you that. First, I would like to discuss about how this process is done. First of all, a plastic sheet. Okay, plastic sheet is preheated using heater, radiant heater or electric heater or any other means of heating that plastic sheet. Sheet is heated, and then sheet is clamped onto the top of the cavity. The hot sheet is clamped on top of the cavity and hold securely in that place so that no air can get into the space. Okay, no air should not come into the space in such a way. This is a three-dimensional object. Actually, we're seeing in the cross section. Okay, middle cross section. And there is a method to apply the vacuum. That means suck out the air from this region. You take the air out. When you pull the air, then since the material is softened due to heating, then material get extended and takes the shape of the cavity. Okay, takes the shape of the die or cavity, whatever you say, or mold. Okay, And when you use the vacuum pressure, the material gets stick on the surface, and then once the material is cooled, then you can take it out. Okay, that is the simple process for vacuum type. And this is the negative type. And for the positive type, it's not kind of positive mold, like it's a convex type structure. You heat the plastic part, and then you clump these two part. If you clump, this one is in here, and this one in here, and this one in here, then what will happen is that the material will be like this, right? Material will be like this. Sorry. Will be like this. Okay. And then when you in here, okay, material will be like this. Whatever. And then these are the places where air will be trapped. Okay, and there will be space in here. Actually, there will be some vents in there, so that the air can be sucked out from this side. Okay, when you suck out the air, then that plastic material gets stick to the surface of the convex shape of the die. Okay, and then you allow some time for curing, for solidification, and then you take it out. This is the positive type die. And this one is for in the case if you have questions like how the material is getting stressed, so there will be some thickness difference between different region in the different region. For example, if you stress it, the thickness will be reduced in these locations, right? Am I right?
Yes, sir.
You stress it, thickness will be reduced in that places. So to minimize that this technology has came into effect, like pre-stressing type. Okay, you take extra amount of material, so that the effect of reduction in thickness in the corners will be reduced. Okay, and for positive type, you can use this the vacuum drawn type. Okay, number one. And for number two, you pre-stress the material first. Okay, pre-stress the material first to get the uniform thickness all over the material, and then you place it into the mold, and then you apply vacuum in this direction. And you can also apply the pressure, positive pressure, from this way to get the same effect. Okay, you can either use vacuum, or you can use the air pressure on the top, or you can use both of them simultaneously to get better output. And usually these clearances are very small, so that the material cannot penetrate through those. Okay, through those places. In case you have a question like, since the material is almost kind of molten, so it can pass through these places and create complication. So you should not hit the material should not make the material liquidy or very low viscosity, so that it does not penetrate through these small holes. Okay, there will also be hole in the middle. Next one is pressure type. We have already seen this one. Like this step is same for the pressure type. In this case, instead of applying vacuum, you use air pressure. Okay, to get the desired output. Also, at the same time, you can use the vacuum method. Both of them you can use together or separately. And last one is the mechanical type. In the mechanical type, you don't use air pressure or air vacuum. Instead, you use the positive die to extrude it, like in the metal forming process. I think you have already studied about that. In the metal forming process, there is a term called drawing, cup drawing. It's similar to that, the drawing of the cup-like shape to produce certain structure. The heated sheet use a positive mold, and you press it, and air will get out in this way, so the material get formed. Okay. All right. Do you have any question in here?
Sir, for the exam of this type of topics, should
Yes.
we draw these sketches?
There will be some drawing. It's not that complicated, is it?
No complicated, but it will take time. I think
Then,
the mark should be according to that, sir.
yeah, definitely. When we make questions, then we always think about the students, like how long it will take for them.
Thank you, sir.
If the number worth, okay. So we always think about that. So don't worry about this. We'll definitely, and you will have like 4 hours for this final exam. So you'll have sufficient amount of time and also sufficient amount of questions, so that you can adjust the time with the questions. I think it actually you will not need like 4 hours to complete this exam.
Sir, 4 hours is very tiring, sir. 3 hours is good enough.
3 hours is good enough, but we have the provision to take the exam for 4 hours. Okay.
Sir,
You cannot actually skip that one. Yeah, sometimes we can do like 3 hours, but I think the question that I will produce will not take that much time. Okay, so I hope it will
sir,
be.
that is very nice. So kind of you, sir.
Yes. And self-study, there is a that's product design consideration from Groover's book. Groover's book that I have given you. You need to carefully study this product design consideration in here for the different type of method. For example, for injection molding, for compression molding, or any other plastic processing, there are some things that needs to be taken care of, and those are things are discussed in here in the product design considerations. This one is for your self-study. If you have any problem understanding that, send me an email. Okay, just send me an email, or you can directly contact with me. Okay.
Sir.
And in the next class, we'll be discussing like composite and rubber processing, how to manufacture composite and rubber to produce effective materials for daily use. And for this today's lecture, if you do have any question, overall.
No, thank you, sir.
And at the beginning, if I'll just, this is the end of the class, but I have some things to talk about. So I'm stopping recording and then